Hey guys, welcome to lesson 3. So pause the video and try the warm-up. You can use the calculator on this question. The question says the rate at which people enter an auditorium for a rock concert is modeled by the function r given by r of t equals 1380 t squared minus 675 t cubed for t between 0 and 2 hours. R of t is measured in people per hour. No one is in the auditorium at time t equals 0 when the doors open. The doors close and the concert begins at time t equals 2. Okay, so we do not have an initial condition and our R of t equations given to us. So it's asking us how many people are in the auditorium when the concert begins. Again, how many has to do with amount. Whenever it has to do with amount, we are going to find the integral. So I'm going to find the integral from 0 to 2 of r of t dt, which would be from 0 to 2, 1380 t squared minus 675 t cubed. You can actually take the integral without using the calculator also, but use the math number 9 feature and plug that into the calculator and you should get 980 people. Yes, again with these questions it's very important. I'm going to highlight the fact I've been saying that you must show your setup. Even if it's a calculator question, especially when it's a calculator question, your setup is very important, and then of course your answer. And if it's asking you for the units and all, just put them, but your setup is very important. Then you can just put the whole equation into the calculator. You don't need to show any work. So part B, it says find the time when the rate at which people enter the auditorium is maximum. So I'm looking for my absolute max here, right? So this is my absolute max. Justify your answer. So what do I do? Anytime we are doing our absolute max or mins, we always look at our table. So let me switch color. So this is going to be my x, or I would say t here, and this would be r of t, right? Your endpoints go in there, so your endpoints are 0 and 2. And in order to find your critical value and your critical values, right? Your critical values, how would you find that? You will do r prime of t. You can actually put that in the calculator and find the derivative of it, or we can do it by hand also. The derivative of r of t would be 2760 t minus 2025 t squared, right? So put that into y1 and you can find these zeros, so wherever it hits the x-axis, and that number is again round to 3 decimal places. 629 actually did 4. And now just find those values at this number. At 0 it was just 0, then at 1.3629 it is going to be 854.527, and at 2 it would be 120 people. So your R of t would be 120. So what is your maximum? It is at this value. So absolute max rate is 854.527 people per hour, which occurs at t equals 1.3629. Okay, so now part C. Part C says the total wait time for the people in the auditorium is found by adding the time each person waits, starting at the time the person enters the auditorium and ending when the concert begins. The function W models the total wait time for all the people who enter the auditorium before time t. The derivative of W is given by W prime of t is equal to 2 minus t r of t. Find W2 minus W1. The total wait time for those who enter the auditorium after time t equals 1. So what is given to us here, our W2 minus W1 is our displacement, right? That could be found by taking the integral from what? From 1 to 2 of W prime of t, right? It's a weird way of asking the same thing, but that's what we are doing. So this is displacement, which we know. So we can set up the integral. It would be from 1 to 2 W prime of t. Again, this is a calculator question, so you can just put that in the calculator, which is what? Right? They asked you the same thing, which is same thing as writing 1 to 2, 2 minus t and r of t dt. So put that into the calculator. So you're basically putting this in the calculator, 1 to 2. This is what we're looking for. So in place of r of t dt, I am going to type in my function, which is 1380 t square minus 675 t cubed dt. So put that whole thing into the calculator and you should get 387.5. So the total wait time for people who entered the auditorium after 1 hour. Okay, now part D. On average, the minute I see the word on average, I know I'm going to be looking for my average value. On average, how long does a person wait in the auditorium for the concert to begin? Consider all people who entered the auditorium after the doors open and use the model for total wait time from part C. So it's basically asking me my total wait time, right? The average value. So how do I find the average value? Remember in the beginning we found in part A, we found it was 980 people, right? The number of people. So it's 1 over 980 and then the integral from 0 to 2 W prime of t, right? So 0 to 2 basically represents from time t equals 0 when the door opens till the when the concert begins, and W prime of t represents your rate of wait time, which we found in which was given to us in part C, and you put that whole thing into the calculator, right? And basically that would be 0.776 hour per person. Okay, so let's start with example 6. Again, this is a calculator question. This whole lesson is calculator based. So let's get going. A particle moves along the x-axis so that its velocity v at time t is between 0 and 5 is given by v of t equals ln of t square minus 3t plus 3. The particle is at position x equals 8 at time t equals 0. So this is our velocity function. We are given our initial condition of what? X of 0 is equal to 8, or S of 0. Here it's saying X of 0. So find the acceleration. So how do I find my acceleration from my velocity? Remember, your acceleration is the derivative of velocity. So your v prime is same thing as saying acceleration. So this is a calculator question. You can do it, but it is a very simple derivative. So ln of this function would be 1 over t square minus 3t plus 3 times the derivative of the inside, which would be 2t minus 3. So I can rewrite, I can find a of, I want to find 4. Just substitute in 4 for t and I will get my answer. So 2 times 4 is 8, 8 minus 3 is 5, 4 squared is 16, minus 12 is 4, 4 plus 3 is 7, so 5 over 7. That's my acceleration at t equals 4. Part B. It's saying find all times t in the open interval from 0 to 5 at which the particle changes direction. Again, when does particle changes direction? When your velocity changes sign. right? So we can actually take our velocity equation and set it equal to 0, and we can find our values for t. Since it's a calculator question, you're literally looking for your if you're looking at the graph, you're going to look for the values where, or the interval where the graph is below the x-axis, right? So if I was to do this algebraically, I'm going to take my velocity equation and set it equal to 0. Right? I'm going to raise it to e. How do I get rid of ln, right? And this would be e to the 0. This would be just the el and ln cancel out. I am left with t squared minus 3t plus 3 equals 1. Set it equal to 0. I get t squared minus 3t plus 2 equal to 0. T minus 2 and t minus 1. These are my two factors. I'm going to t it off. So I got t equals 2 and t equals 1. So these are my two places or two zeros, right? So let's find it out. Let's do a velocity number line, because it's asking me the time where the particle turns left. So over t is from 0 to 5, right? My two numbers that will go on the number line are, this is, remember, my velocity number line, 1 and 2. And now what am I going to do? I'm going to take a number from each interval and I'm going to check whether it's positive or negative. And again, I always like to substitute in this equation in my factored form. It's so much easier. If I take a half, let's say half minus 2 is what? A negative number, and then half minus 1 will also be a negative number, so this would be positive here. If I make a number greater than 1, which would be 1.5, let's say, this would be negative and that would be positive. So this would be negative and this would be positive. So I have negative over this interval, meaning what? I'm going left when velocity is less than 0, which is the interval from 1 to 2. Part C. Find the position of the particle at time t equals 2. So how do I find my position from my velocity function? So your position is basically the integral of velocity, right? So I'm going to take the integral. So I'm going to set it up. It would be what? X of 0, which is my initial condition, and then the integral from 0 to t ln of whatever that is, that function v of t, which I'm going to write it here. So if I'm doing x of 2, I'm going to be doing, my initial condition is what? 8, and I already found the you can actually put this in the calculator, because finding the integral would be a little challenging here if you haven't really done that. So it will be 8.369. okay, so the position of the particle at t equals 2 would be 8.369. Part D. Now it's asking me to find the average speed of the particle over the interval from 0 to 2. So average speed has to do with your average values. So over the interval of 0 to 2 would be 1 over b minus a. So b is your 2, a is your 0, and then the integral would be 0 to 2, and speed has to do with absolute value of velocity dt. Put that in the calculator and you would get 0.371. okay, so now I want you to actually finish up the two questions that you may have on your own. If you have any questions, please feel free to reach